Germanium and silicon diodes conduct at 0.3 volt and 0.7 volt respectively. In the following figure, if germanium diode connections are reversed, value of V naught changes by. So, looking at the diagram, now so this is 5 kilo ohm and this is 12 volt, this is silicon and this is germanium. See, this has got a potential barrier of 0.7 volt, the silicon. Germanium has got a potential barrier of 0.3 volt. So, whenever the applied voltage reaches 0.3 volt, germanium starts conducting very easily it starts to conduct. So, we have to calculate what is V naught in that case. So, that is 0.3 volt drops here, 0.3 volt drops here. Okay. So, current in the first case is I1 in the first case when both are forward biased. When both germanium and silicon diodes are forward biased, what happens? I1 is 12 minus 0.3 divided by 5 kilo ohm. So, that is 11.7 into 10 to the power minus 3 divided by 5. So, that is when you are dividing by 5, you are doubling the number and putting the decimal. So, this is 234 and then you are putting a decimal here, one place before where the decimal actually is. Doubling the number when you are dividing by 5, say 2 by 5 if you do, it is 4, you are doubling the numerator but putting the decimal, that is 0.4, that is how it is. So, it is 2.34 milliampere. Now, when silicon diode, germanium is reversed. When germanium is reversed, it sorts of opens up the circuit. When germanium is reversed, see, if germanium is reversed like this, it is in reverse bias, no? It opens up the circuit. Then the current will not go through this. Here current is 0, current will only go through the silicon. So, I2 will be then 12 minus, what is the voltage drop when it reaches to 0.7? 0.7 it goes through the silicon diode, 5 into 10 to the power 3. So, that is 12 minus 0.7 is 11.3 divided by 5 into 10 to the power minus 3. So, you double this number, this will be 22.6. So, 113 will be 2.26 milliampere. So, the change in current is I1 difference I2, that is around 0.08 milliampere. Change in current is 0.08 milliampere or voltage change. Now, this is a current I2. Voltage now V2 for the second time is 2.26 milli into 5K. So, that when you are multiplying, you make it half the number and put a decimal later. So that is 11.3 volt. What about this? Here it is 2.34 into 5. So that is 11.7 volt itself. So you need not have to calculate current, okay. If they ask you the current change, this is the answer. Otherwise directly you can calculate 0.3, so it is 11.7 here, 0.7, 11.3 here. Right away you can calculate as a shortcut. Change in voltage is 0.4 volt. Change in voltage is 0.4 volt. So option B is the right answer.